Okay, example 3. Solve this system of equations. 2x minus 4y equals 8 and x minus 2y equals 1. Well, I noticed that on the left side, the second equation is 2 times the first equation. But the right side is not 2 times the value on the first equation. There has to be a 16 there. So these are not the same line, they're parallel lines. Parallel lines that are not the same. And so the system is inconsistent, there's no solutions. I can tell that right off the bat without having to do any computation or any additional computation. So I wrote that out for you. Right? So these two lines are parallel but not the same. A line is always parallel with itself, right? But these are not the same line. And so there's no solution. There's no point that lies on both those lines. So it's inconsistent. Right? And that would be the answer. So you're done. Now what happens if you don't notice this? It's much smarter to notice it, okay? If you don't notice that the system is inconsistent, and you just do substitution, you get x equals 2y plus 1. You substitute that into the first equation, you get 2 times 2y plus 1 minus 4y equals 8. And you get 4y plus 2 minus 4y equals 8. And you'll get 2 equals 8, because 4y minus 4y is 0. 2 equals 8, that's always false. So that's what we call a contradiction. So you're assuming that there has a solution. You find out you get a contradiction, that means there's no solution. So now you just write down no solution. Okay, so that's the other way you could get to the same answer. It's just smarter to notice right away that it's inconsistent. All right, so that's the reasoning that goes into that.